Hello, welcome back to HSC Maths Tutoring with Nathan, and today I'm going to be covering permutations. So this is one of the least favourite and more tricky topics from the HSC 3-unit course. So I'm just going to go over a broad example that covers about 90% of permutation type questions. There are a few other types, but this type of question will show you how to do most type of permutation questions. So the example here we have is consider the word founder, and we want to find the total arrangements for all these options from A up to G. Okay, so what's the process for permutations? Well, what we want to do is basically want to draw available spots. Okay. So in this example, we've got 7 letters, so we have 7 available spots. 3, 4, 5, 6, 7. So next, what we want to do is fill in special conditions. Excuse me, pardon my writing. Okay, and after we fill in special conditions, we then want to fill the rest. And basically we then multiply across, and if need be, we'll just scroll down a sec. What we do is we add different cases, so we'll get to that later. This is an optional step, it depends if the question has multiple cases. So let's go through a process. We'll come up and start with A. Now, just note, I do not use the NPR function to do permutation questions. I just like to fill the spots. It's a much more like common sense method, and it makes a lot more sense. So no restrictions. So we've got no restrictions. We've got 7 spots. 4, 5, 6, 7. So we've got 7 spots. Now in the first spot, I've got 7 letters to pick from. So that means 7 options for the first spot. The second spot, I have how many? Yep, that's right, 6. You get the idea. Then there's 5 letters left here. There's 4 letters that can go there. Then there's 3 letters left there, 2 letters left there, and 1 letter left there. So we can skip step 2. As I said, there's no special conditions. We fill the rest, and then we multiply across. Now what you'll notice, 7 times 6 times 5, 4, 3, 2, 1 is, by definition, 7 factorial. So I'm assuming if you've done permutations, you will know what that notation. And that's the answer for no restrictions. Very simple. So I hope no one has any issues with that. Now we have a special condition here. Vowels and consonants alternate. Well, 90% of the perm and com questions, there are special conditions. Okay. So let's fill that out first. 3, 4, 5, 6, 7. So what you'll notice is there are 4 consonants, F, N, D, R, and 3 vowels, O, U, E. Now that means a consonant has to go first, because then they alternate. If a consonant doesn't go first, then we end up with 2 consonants at the end, and then we fill in the vowels. Now, so that's what the letter has to look like. Consonant, vowel, consonant, vowel, consonant, vowel, consonant. So what that means though is the consonants, there's 4 of them, they can be arranged. These consonants can arrange themselves in these 4 spots. So there's 4 consonants that can go there, 3 there, 2 there, 1 there. So that's 4 factorial there. And the vowels, you have 3 that can go there, 2 that can go there, 1 can go there. So that's 3 factorial. And remember, step 4, we multiply across. So we've got 4 consonants and the 3 vowels. So the total would be 3 factorial times 4 factorial. So that one's not too bad. C, the word starts with N and ends in D. Well, special condition, we start with N. Then we got 2, 3, 4, 5. 5 spots later, and then a D right at the end. So those are my special conditions. N and D have to be at the start and end. Now I've got 5 letters left, and let's fill those in step 3. Fill the rest. So 5 can go there, 4 can go there, 3, 2, 1. We times across, and that's just simply 5 factorial. So you can see this spot diagram, as I call it, really simple and really helpful. D. N and D are together. This is a special condition. So the N and D are together. 2, 3, 1, 2, 3, 4. So what we do when we want things to be together, we're going to treat them as one letter. So you can pause the video and make a note here. If you want things to be together, treat them as one letter. And I like to put a rectangle around it just to notify that is forced to be there. Okay, so now if you think about this, this is one letter, and then we have 5 other letters. So in total, we have 6 letters in total and 6 spots to fill. ND is considered as one letter. So in total, that would be 6 factorial, right? Because we've got the 6 spots to fill in. ND is now one letter at 6, 5, 4, 3, 2, 1, as we had up here. But there's one more condition. You got to be careful here. They said N and D are together. Don't forget N and D, they can swap positions. So that means we need to multiply by 2 for the case N and D swap. So don't forget that. Okay, next we are E. Alright, F and R are not together. Okay, that would be multiple cases to consider. Because if F and R are not together, there's going to be 1 gap, 2 gap, 3, 4, and up to 5 gap between them. So that's 5 different cases to consider. So here's a special trick. We look at the complement, which is the opposite. Right? So if F and R are not together, the complement is F and R together. Alright? And if this is a trick, a lot of questions will actually help you. So if you look in D, we already actually, found when N and D are together. Now F and R together is the exact same thing. There's no difference between F and R there or an N and D. So that is just 6 factorial times 2 from D. So then the event we want, because the complement's the opposite, so we just get the total minus the complement. And the total, if you look back up here, is 7 factorial. That's no restriction. So the total, I'll just make a note there for you. In terms and commas, that's your no restriction. So then it's just 7 factorial minus 6 factorial times 2. So that one's not too bad, okay? Because that's a very powerful trick here, the complement. So don't forget that trick. Make sure to pause the video and take some notes. F, alright. There is 1 gap between F and R. So what's happening here in F is we have this situation. We are forced to have 1 gap between F and R. So the only way to force that is to treat F and R as one big letter. And then there is, a gap between them. So that means we have 3 letters as one letter. So that means from 7 now we have just 5 letters. So we've got 1, 2, 3, 4, 5 spots to fill. Right? But what I like to do first is how many different letters can go here. Right? So that means there's actually 5 letters that can go between F and R. And then we can start arranging it. So then there's 5 choices for that. This is considered one big letter. There's 4 choices for that, 3 choices for that, 2 choices for that, and 1 choice for that. So that equals 5 factorial times 5 because of the 5 letters that can go there. There's 5 different cases of F and R have a gap of 1. And then don't forget, lastly, like we do when they're together, they can swap. So that's times 2. So that's the trick when we want to force letters to have a certain number of gaps. We just treat it as one big letter and fill in the gaps in between. And lastly, G. I like G. This is a really quick question. F is somewhere to the right of R. In an exam, I wouldn't expect you to write this out, but I just want to illustrate. F is somewhere to the right of R. I said that right? Yeah. So F is somewhere to the right of R. So then there's F here, then there's R, then F could be there, and then all the spots there. There could be a gap of 1, there could be a gap of 2, 3, that's a shocking F, 4, and then finally 5. That's 6 cases. So if you were doing this method, you have to work out each case, which I've shown you how to do. I've shown you how to do that case, I've shown you how to do that case, which means we can do these 2 cases straightforward, and I've actually shown you that case earlier in the question. So we technically have the answer to 3 of these, so you could actually just work out the other 3, but still that's going to take a while. So one technique I've shown you today is complement. If there's too many cases, you look at the complement, because that will make life a lot easier. But the complement is F is, so I is to the right of F. So that's going to look like that. So you'll see in a second it's equally, and keyword here is equally as bad. That's also 6 cases. That's the complement. So here's a very powerful trick. When you notice the complement has the exact same number of cases, it's equally as bad, or equal by symmetry. So this leads to symmetry. That is shocking, the M's overlapping, which means the event equals the complement. And because if you look up here, the event is total minus complement. The total is your event plus your complement. So that means if the event equals the complement, it's just half the total by symmetry, because they're even. And the total, which we already worked out was no restriction, was 7 factorial. So see how quick that is to find? Like, you don't actually need to write this in an exam. I'm just showing you this. This can be done in your head. You can be like, because this thought process can be done in your head, how many cases there are. And then you're like, oh, there's symmetry here because they're equal. And you just have to write this down. Symmetry, therefore the event's the complement, half total, half 7 factorial. So that there covers the majority of permutations, set around 90%, 80 to 90% roughly. There is a repetition, there is arrangements around a circle. But arrangements around a circle follows this process but with one extra condition. So if you enjoyed this video, make sure to give it a like and comment below. Also comment below what future videos you would like to see. And don't forget to subscribe and share with your friends if you enjoyed. Otherwise, I'll see you next time.